Okay, all right. Welcome to this pod. Today's guest is someone I've honestly wanted to grill for a while. If you haven't touched anything post training, RL, or even just scrolled through AI Twitter, Tokenbender is always in the mix. But instead of just reading his tweets out loud, I figured out we'd just cut straight to the fun. What actually happening behind the scenes in this whole LLM chaos? So before we getting started, first I want to introduce what Ground Zero is. So at Ground Zero, we do a lot of foundational stuffs. We have taught machine learning, deep learning. Currently, we are running a series on linear algebra. We also have a recent collaborations as well with the Deep ML and Marimo, where we have uh, this interesting notebooks to solve. And recently, we did an interesting deep reinforcement learning session as well with Shashank from MIT. So I guess this is all about this gentle introduction. We can get started. So about Tokenbender. So first, I want to welcome Tokenbender for anyone who has been living under a rock or is allergic to leaderboards. You have built models like Codecherrypop, top the charts, and actually shift stuff that runs on a laptop. Not some like huge require huge compute, but more importantly, you have always seemed to have the most unfiltered takes. So I'm honestly just here to see what you will say when there's no character limit here. So thanks for joining, and we can get started from here.
Hey Manchu, thanks for having me here. Yeah.
Um, so starting with the first, first I want to ask, who is Token Bender really? What's the journey been like from Intel India to now pushing the boundaries in post training and RL for LLMs? What was the specific moment that flipped the switch for you? Please.
Yeah, so I was a technical lead in Intel in the server firmware division, and you may have you, you guys might be familiar with the term BIOS, right? And also
Yes.
with firmware. So
Yes.
yeah, so you can think of it like that I used to work in a team which was on the server side where we used to deal with what would be the firmware that would go into all the platform units on the server side, basically all the data centers that you have. So our clients and our and our cu- so our clients and customers used to be companies like Amazon, Google, and and so ra- rather than basically what people really think of it when they hear the name Intel, which is essentially a laptop processor making company, right? So my exposure was on the server firmware division side, and it was not at all related to AI, like in any direct or indirect way. It was just a buzzword to us, like most people around me at the time. And what really happened was that during COVID, we faced a huge headcount crunch. There was government mandated 5% bar that you can't really have more than 5% people in the office. And because most of our units were op- um, so most of our units really required a human to be there, because these server platforms used to be quite complex and they could break in n number of ways. So there always used to be some contractors which were really needed in the lab for any situation which may arise unexpectedly. And in those cases, so in that scenario, when we were really there and we faced the 5% headcount crunch, we didn't really know what to do. Around that time, I just picked up natural language processing, and I thought that since what we are really dealing with entirely is server logs, test cases, code reviews, features, and your documents, which really detail out the specifications, which really detail out our specifications. So I was like, okay, I'm really surrounded by text everywhere, and if I can really extract out some intelligence through this, which can help me uh, reduce the number of people we really need to get this thing done. And in just 1 week, I was really hooked to it because it was really interesting. I was having lots of fun. I was also lucky to have built a solution much early on, which actually allowed us to sail through the COVID headcount crunch. And with just 5% or 10% headcount crunch later on, we didn't really lose any milestones. In fact, in fact, we were able to like uh, save lots of money because we were not relying on that many humans, as well as being able to control the quality that we were delivering. And that exposure introduced me to the world of AI, specifically from natural language processing side. But my exposure to it was primarily from engineer perspective, because my main job was something else. I was leveraging artificial intelligence uh, in ways where it could help me make recommendations, classifications, summarizations, or yeah. So basically, my entire exposure to it was just from uh, application side, and it continued like that, where I just kept on applying AI here and there wherever it used to fit, until I saw GPT-3 API outputs in late 2022. And when I saw that, then I was quite surprised, because earlier we used to have specialized models, which were like, uh, this is a summarization model, this is a recommendation model, this is a classification model, this model is for named entity recognition or something, right? And when suddenly when I'm seeing the output, and here is a model which is taking care of everything, like it's actually taking input into a human uh, text format, which is natural language. It's taking input into a completely natural language format, and it's analyzing the request, and it's also answering the question automatically. And if something needs to be done in sequence, for example, if the answer requires summarizing something as well as extracting some information, it was capable of doing both at the same time. When I saw that, it was like um, something really changed, and I realized that the next decade is going to be dominated by this thing. From that point onwards, my own job was secondary to me, and what I really cared about was really understanding what was happening and mastering it. From that point onwards, early 2023 to late 2023, I completely focused on studying as much as I can, trying to learn everything at once. It was really hard, because on one side I was trying to also see how to apply these things so that they can be useful to me, and on the other side I was looking at all these research terms and papers which I never had any exposure to. But when Llama 2 released, then um around that time, lots of people were forming different kinds of intuitions. And around that time, we used to have fine tuning only relevant in terms of role play. So we used to have Samantha, we used to have um Ernest model, which was useful for role play or some basic chat, right? But none of the small models were really useful for anything which actually made money. For example, if someone was to ask that, uh, can I use this local model in any way for coding or anything else, then the answer was no for that. People used to use quantized 70 billion parameter llama 1 models on llama 1 models on local llama subreddit, and just like that, we, we just had a very small community which only was interested in doing some role play, basic chat stuff, right? uh, I followed my intuition. I actually went through the entire llama 2 report, and then I followed my intuition, and I figured that it was that these models, like when llama 2 was released, it didn't have lots of code. So I was like, okay, I think this model is really hungry, and uh, if I just expose it to enough uh, data which is clean and good, I might be able to actually improve it. So then Codecherrypop was born, and the model was actually good. What people really loved about the model more than anything else was that it wasn't just a dumb model which was like only good at one thing. It was actually good at many things. It was a friendly model which also which you could also like play with, act as an like it would act as an assistant for you, and it would also take care of your tasks. So so then that model exposed me to the broader community of people who were into fine tuning, uh, doing lots of stuff behind the scenes. And once I really got a taste of that community, so from that point onwards, I just like kept on building stuff.
Really interesting. And I remember at one point of time, you have told me like you have background in electronics and you really enjoy the principles of signal and systems, communication and stuff. So if you can give a general exposure to how you think on those levels to our audience, that will make sense, I guess, to a lot of people. I
Yeah,
guess,
so
yes.
yeah. So as I said that I don't really come from a computer science background. And because of that, I don't share lots of ways in which people look at information by default. Because by the time I picked up uh, trying to study deep learning for large language models or anything else, by the time I was already kind of a specialist or an expert in my previous domain, and I had to throw away all the prior knowledge which I had to actually come here. But the thing is that all my intuitions from my exposure to electronics, communications, signals, and basically computer architecture design. With all those things, I would just like whenever I was studying these things, I would just see those patterns everywhere. Right. For example, if someone was to ask me about speculative decoding, right? So anyone who has studied pipelining in computer architecture can just look at the diagram of speculative decoding and immediately say that yeah, it's essentially pipelining, which is just your fetch instruction, decode instruction, execute instruction, right? And just like that, for anything which we're working with in LLMs, where essentially we were leveraging GPUs, which are massively parallelized, right? Then lots of things that we're doing under the hood are actually optimization problems. So there is just so much information which, right from the level of linear algebra, probability, right from that level, which finds lots of commonality with uh, your signal systems and digital communication theory. There is just so much intuition which is already present in those subjects, which, if you actually looked at that, then you would be able to translate the information which you see elsewhere in deep learning or large language models and be able to find uh, parallels. For example, when someone says that these autoregressive models uh, get worse and worse as the context increases, right? So for a person like me who comes from signal theory or communications background, to me it is just an information which is being passed across multiple channels, and as the length of the channel increases, we accumulate more and more noise. We accumulate more and more noise, and the signal to noise ratio keeps on decreasing. So a point comes where whatever is the threshold, the signal to noise ratio goes below that, and the actual information or the actual target where we really wanted things to be have gone completely off the rails. So yeah, so you would find such parallels everywhere, and you could say that most of these things are an easy hack to build your intuition when you're like really studying these things. Yeah.
Oh, yeah, interesting. And most of the college grads really kind of complain about those hard signal system subjects. But I guess this will give enough motivation for them to actually understand this thing to relate more stuff on about LLM research and AI. So yeah, this is one thing. Next, I would love to know what has been the journey with Codecherrypop. So many people are obsessed with the massive parameter counts. After building Codecherrypop, do you think small optimized models are underrated? Or what do people miss about going small?
Yeah, so Codecherrypop was like 2 years back, and even around that time, most people didn't expect anything from small models. Even though we kept on having performance improved again and again for the small models, but still, even in today's date, you wouldn't really see a 7 billion parameter model deployed anywhere in production, right? And uh, one of the biggest reason is that you can always get a better performance on a frontier API model, or even if somebody has GPUs and they're hosting their own model, then they would rather try to use a quantized bigger model, right? Because the quantized bigger model performance is much better. But one intuition that I've always had about these models when it comes to small language models is that I really look at them not as generic models, but rather as extremely specialized tools, um, where I really look at them in terms of, okay, so just like you have uh, let's say you have a computer unit, right? So in
Yes.
that computer unit, you have basically your memory unit and your processor unit completely divided. Okay. If you wanted to imagine an equivalent of that in large language model world, then you would ask yourself this question: is it possible for me to actually create units where we can create large language models which are just extremely efficient function calling or tool calling units, right? So imagine 600 million parameter quen model, or we can imagine even lesser. Let's imagine like a 250 million parameter model. Okay. And then imagine that it has 100% function calling accuracy, and it has 100% function calling accuracy not just on extremely simple tasks, but even on things which require chaining, which require nesting, which require being able to refer to the right context and then pick uh, the right item to call unambiguously over much larger context in an agentic fashion, or something like that, right? So for all of these cases, you would see that if you're able to achieve that with an extremely small model, then you can start keeping memory banks, then you can start keeping caches, then you can start leveraging databases, then you can start just uh, storing information rather than always relying on LLMs for real-time activity. Because even though large even though huge models which like 70 billion parameter or anything bigger is quite capable in terms of performance, but they're also very costly to run and very slow to basically use in inference. Right? These small models can be lightning fast. These small models can be faster than a human can perceive the change. Like if anybody has watched uh, Spotify Spotify related show on Netflix, then there it was mentioned how basically anything lesser than 300 millisecond or something was imperceptible to the human eye. So if some action is happening so fast that it is taking like 300 millisecond or 400 millisecond, then to the human who is experiencing that, it is seamless. It is happening in real time without any transitions, right? So once you have things like that happening for you, then automatically what ends up happening, then automatically you can just completely convert everything in terms of and tasks and units that you want to interact with. Okay. And in most of the businesses or use cases, you would see that, for example, if there is a shop and that shop has an online portal or interface or something, right? So most of the people who want to go and do something there have very fixed patterns. So let's take the example of Zomato as a food delivery app, right? So you would see that there would be some hot items, there would be some popular restaurants, and these popular restaurants would have some popular choices. And 80 to 90% of the times, the same restaurants get picked and the same food items get ordered, right? Now, all of this stuff is happening quite frequently. If we rely on LLMs to query this information each and every time, and uh, and read it up, analyze it, and then service the same query, which has which is being asked more than 80% or 90% of the time, right? Then it is a huge waste of intelligence, because you don't because even if you need that level of intelligence for the let's say for the first time or the second time, right? But if the same question is being asked 80%, 90% of the times, then that entire process can be saved. It can be cached, and all the actions that we are taking can be completely thrown to this really really small, lightning fast, small model. Okay, and we're going and we're getting really really close to that. So right now, Quen is still focusing
Hmm.
on making small models generic by so they take 30 billion to 30 trillion or so uh, tokens, and then pre-train, post-train, even the 600 million parameter model on that, right? But
Yes.
let's say that if they really really started caring about hyper specialization, and we have already seen that these Quen models have gotten really good. So let's talk about hyper specialization. And when once we have hyper specialization, then you would see that such kind of applications would become possible. And I'm sure that by the end of 2025 or 2026, we really, I really expect something like this to happen. Yeah.
Interesting. And it's a cool. This also reminds me of your take where you said every tool, every system we touch, we should treat it like a genie and assume it works like perfectly, assume it can do anything you want. And when it hit failures, because at some point of time it will, so we should probably do a back prop or work backwards, fix the ways of working with it, and have believed that it can deliver magic at some point of time. So yeah, I can relate to this, and this is very general intuition. So I guess this is all about Codecherrypop, and we can. So I'm also curious about the series. I saw on a Hugging Face like you have to partner in time and role play series. So if you can throw some light, what is it about, and how you come up to these names, and what is the idea behind? Yes.
Yeah. So I was really once I built Codecherrypop, and people loved it not just as a coding model, but they also loved how friendly it was, or how it could just adapt into different kind of situations. Like if you go on local llama and search Codecherrypop, then you would see multiple people talking about it, and mentioning even like it was created in July 2023, but you would see people even talking about it by April 2024 or something, where they just mentioned that uh, it really was able to work with the user in a quite seamless manner, which they really used to enjoy, which they used to find absent uh, anywhere else. And and when people came to me with that kind of feedback, I was like, okay, yeah, like uh, this this is something which is really absent uh, anywhere, because around end of 2023, even ChatGPT or anything else that we used to have, these models used to be extremely apologetic, extremely restricted in the way they would respond. They were not friendly at all. These models would not be able to understand your intent, and uh, a- and it was a bit janky to work with them. It wasn't really comfortable, right? So I used to feel that okay, we are building these small models. Is it really possible to have some sort of emotional intelligence in a small model? And if on top of having emotional intelligence, because people were already building role play models and uh, character bots, or other kind of things, right? Even in those cases, I was like, okay, why can't I really club these kind of things? Why can't I have a coding model which is also good at function calling, which is also good at uh, role play or acting as an assistant? Why can't I have all of that in a single model? So Pick series was the first series which tried to tackle that anywhere. Like you would not find any work which actually tried to combine three utilities into one and then make the model really good in that. So I started working on that, and I wanted to have a generic model uh, which was really really good at these three areas. And for that, I built the partner in crime series. Now it's really now this kind of behavior is really present in all the top models. So even if GPT-4o is dumb at times, but still it is capable of role play or acting as an assistant, or some people even treat these models as some sort of therapists, or like they go and uh, they go and discuss general problems in their life, and also use these for coding as well. Like these models are also applied elsewhere for function calling and stuff. So now all of these things are already solved on the frontier level, but for a really really small scale, like 7 billion parameter scale, I wanted to build that, and I created the partner in crime series. Now for the role play series. So so the thing was that whatever I was trying to build, I realized that okay, when I built Codecherrypop, I got familiar with the coding datasets, and I used to look around and then understand which were the best coding datasets, which had higher level of contamination, which of these used to bring out performance with very less number of rows. So all that information was really uh, something which I was extremely familiar with. But what I wasn't really good at was understanding that okay, if these models had to display some sort of emotional intelligence or act as if they were part of a play, or if they were to be applied as a character model or anything, then I lacked that information. So there is a company called Chai AI. They I'm not sure if they do it now, if they do it even now, but they used to host monthly they used to have monthly contests where you can go and submit your model as a model builder, and if your model is actually loved by their users, then it would come to the top and you would gain prizes. And for 3 4 consecutive months I actually won there, and I really loved it. Uh, and in the process I was able to familiarize myself with all the weird things that people were doing to make the model emotional intelligence or quirky or really fun to talk to. Or we used to also talk about some schizo models which uh, uh, which would be created by model merging techniques and all, right? So that was the time when I got familiar with model merging. That was the time when I got familiar with all these different kind of data sets, and uh, and how they would be used to create a model which can act in a fighting kind of game. For example, you may uh, you may enter a prompt and then you actually want to fight with the model. So you write some moves or a scenario, and then the model responds based on that, and then an entire play is happening between you and the character that the model is playing. So I familiarized myself with that, and also gained an expertise in that. So yeah, so 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 you can think of it like it was an attempt for me to actually go and understand all the different skills that a model can have, and how can I grow in that.
Interesting. That's a pretty really interesting story about how, and I guess this will give the audience pretty much idea how these series have evolved and how the thought process has been behind the series. And yep, the next would be like I'll be diving into post training. But before, because I have I've got some questions from audience as well, and have a lot of questions from my end. So probably you can be straightforward, or just as the question goes by, you can probably answer. So
Yeah.
first will be like, how is post training in your books? Like you do a lot of experiments, and we have lived through the pre-training gold rush, and now everyone hyped up about post-training. What's the biggest difference in how you think about building and scaling models now versus now that was 2 years ago? So in that respect, what's your thought processes?
Okay. So actually, post training used to be more fun 2 years back, because 2 years back most of the frontier labs never used to care about post training. They would just focus on releasing base models, and their instruct versions were not worth anything to look at. Then alpaca came, and after alpaca came, then people started looking at everything and then thinking that okay, we can actually create instruct models with really small data sets like 50,000 rows of instruction response pairs, 70,000 rows of instruction response pairs, right? It was something which was extremely accessible to any kind of tinkerer or a hacker who wanted to do something, right? And thus it sparked the first generation of LLM fine tuners, which have gotten really which all have gotten really popular now, and and it continued until Llama 3 was released. When Llama 3 was released, Llama 3's instruct models were extremely tight. Like they were post trained on lots of data, and and it just wasn't easy for anyone to uh, to actually build their own instruction data set and then beat that. And around that time, the most popular RL approach was also DPO, and DPO had lots of issues. I even have tweets where I have talked about DPO uh, reward hacking, or actually, uh, what should I say, that in that even if your data set was something which was like 10,000 uh, pairs of preferences, it would just go down to zero in like the loss would go down to zero in just your 100, 200, 300 preference pairs. And all of us were like really suffering. We didn't really have any better alternatives. RL, the other alternative was PPO. So when DPO didn't work, the open source community primarily focused on two things. One was that okay, those who can do would do PPO, and those who can't do would like would just keep on using DPO and then focus on building better preference datasets, or then every 15 days we used to get a new paper which was about improving DPO in some way, right? But none of those things really picked up. None of those things really were able to bridge the gap. There was lots of effort, but none of those things were able to bridge the gap. DeepSeek released GRPO. GRPO was not as light as DPO, so it was not picked up by the open source community uh, because compute is really a problem, and using SFT, people were actually able to transfer lots of performance gains on these models. And the art of creating synthetic data sets and then using them to improve these models was uh, quite well practiced by the community. So the entire focus used to be around that. That was the period between Llama 3 release and between DeepSeek R1 release. This time period from April 2024 to January 2025. In this period, you can say that like it was a really bad phase for open source post training. Even I had to drop post training around that time because the Quen models or Llama models or anything that used to get released, all of them used to have your 10 trillion, 20 trillion tokens in the post training, and it just wasn't possible to hack uh, uh, when the dataset size was so huge, when the compute demand was so huge, right? And then most most of the people then started focusing on other things like building agents or tool calling units or scaffolds or stuff like that. But right after DeepSeek R1 released, and with the famous aha moment, which was reported by DeepSeek researchers in the paper, that using RL itself, they were able to uh, elicit certain degree of intelligence or reasoning from the model, which was not taught explicitly, right? And this was something which really motivated everyone. In their paper, they also mentioned how they tried R10, where they had no SFT at all, and R10 even worked, but R10 was not good enough. R10 wasn't really coherent in long context or in various kind of situations. So R10 was really interesting, but R10 wasn't really better than uh, your standard release, which was R1. Um, and then from January 2025 to until May, you may have seen like every week we get 3 4 RL papers, and so much and so much information has been dumped out in the public. People have tried uh, a lot of stuff, and it has mostly been centered around RL. So you could say that it got everyone interested into RL, and right when everyone got interested into RL, and uh, even with Will Brown's verifiers library, using which people were doing Quen 0.6b or 1 billion parameter experiments. With all of that, people started seeing lots of stuff on the post training side again, where SFT was the unsexy thing, but RL was okay. Yeah, we really want to do RL, and uh, some people had like correct notions about it. They actually understood what RL could and could not do, but majority people, like 95% people, had some ideas about either RL being good enough to do everything, or it just being let's say that it completely relied on the base model capability, or or it was like you could use it to learn anything even if it is not present in the base model. So yeah, so people had these two binary approaches. Yeah.
Interesting. And as you said, on the post-training side, ultimately it all boils down to how GPU poor or compute poor we are. But in the same line, I have this thought as well. Someone posted, TensorQT posted about his gut feeling about pre-training. So is pre-training actually dead? How much current post-training experiments is influenced by pre-training, like SOTA LLM as far as concerned? So what are your thoughts on this particular notion?
So think of this. So think of the LLM world in terms of um, like I always give this equivalence of research in LLM world in terms of a snake shedding its older skin. Okay, just like that, just like everything that we understand about LLM research in the past, we have kind of grown above it and realized that it has hit the law of diminishing returns. That pre-training, pre-training used to have huge pre-training used to have huge value, because it was like, okay, if you train up to 100 billion tokens, you can gain this level of performance. If you gain if you go 200 billion, if you go 500 billion, then the performance gains would continue on increasing, right? But anything which is good in LLM research gets abused uh, exponentially. So from the scale of 100 billion pre-trained models, 100 billion token pre-trained models, we immediately started seeing a growth. And now the latest Quen 3 models have been released with more than 30 trillion tokens of total data. 30 trillion tokens is huge, because I remember very well last year last year early 2024, uh, there were multiple accounts on Twitter that used to talk about, can we make a bet that a 10 trillion trained model would be released by the end of this year? And that used to sound huge, because around the time the models which were released were like 1 trillion token trained models, right? Because we grew exponentially and kind of consumed all these sources which were present, which were like any database which was present on the web, common crawl or any other corpuses, uh, even data companies, all the data that they had was consumed really fast. Uh, then people went to Anna's archive, picked up the PDFs, ebooks, and everything which was present. Uh, all of that stuff was also put in the training data. And despite all that, we just uh, you can say that almost everyone has similar pre-training data right now, right? And because most of the models have similar pre-training data, then we kind of hit a limit of the performance gains that we can take out of pre-training. Because in terms of the research which has happened so far, no research has happened extensively to squeeze out the performance. For example, we really haven't seen research that given a data set of 10 trillion tokens, can I create a smaller representative data set of the same, which is exactly equal to the 10 trillion token model, but it only takes 1 trillion to train it, right? And then can we keep on compressing it further, right? For example, an equivalent of quantization, but on the dataset size. We really haven't seen anything. So what we see right now is exponential consumption of data which is present everywhere in the open, and not really a way to compress down the need for data. Okay, because uh, right now we are in the dumb phase of the AGI research, where we have seen that scaling works. So we are where we've seen that scaling works, and any lateral research isn't yielding much uh, output. So each and every resource which we have available in terms of human resources or compute or money, anything, right? Everything, energy, everything is being thrown into just one thing, and that is purely scaling. So once everyone reaches the point where everyone has same pre-training data, then it becomes extremely difficult to rely on pre-training uh, to actually get any gains. Then other things started emerging, and if you and what I really referred to earlier as a snake shedding its skin is basically what we really understand about research now. We are going to drop that, and we are going to do something else. When people started seeing lesser and lesser gains from pre-training, then emerged something which we call mid-training, right? And we also started seeing huge growth in importance on the side of post-training. So once people started seeing huge gains, like the amount of gains they would see on working on post training versus working on any research on pre-training side, and also pre-training is extremely costly. So it's not like researchers can can run 100 pre-training runs in parallel and really expect to discover something which works purely by grid search or any other optimization, right? So because pre-training has gotten extremely costly, the focus shifted from there, and focus shifted on the other areas where people started finding improvement. Right now, right now the community, like even on frontier side or open source side, people are familiar that okay, the best gains are on RL side, right? So the AGI priests at the top of these OpenAI, Anthropic, XAI, GDM, DeepSeek, everywhere else, all these AGI priests have declared that okay, if you can create RL environment for any kind of given task, then I can make my model good in that task. Right. So what is really being done is some task-based scaffoldings are being created. Data is being gathered from all those interactions. That data is being added into mid-training for specialization for that domain, or it is being cleaned and formatted for post-training, and then RL is being done on the top, right? So, so this is the interpretation of it. What TensorQT here said that my gut tells me that next race will be getting out of pre-training as soon as possible. It's the intuition that if pre-training is the bottleneck, how can we really uh, tunnel past it? Like we don't really need 30 trillion tokens. The realization or the research breakthrough which might come in some paper later this year or earlier next year, right? Some paper which might come and say you don't really need 30 trillion tokens, or you don't really need 100 trillion tokens. You just need 1 trillion token or 500 billion token, right? And we start seeing a decompressing of pre-training. So that is what it means here.
That makes sense. And also, I guess the Moore's law nowadays is more on the positioning side with RL, with agentic side, and I guess we are probably looking forward to it. So the my next section would be on this RL reasoning and experience only. So we have seen this massive wave of RLHF and post training, but at the end of the day, how far do you really think reinforcement learning can take these next token predictors? Are we anywhere close to models that genuinely think, or are we just hacking around the limitations with clever tricks and better reward signals? And when you actually get into these weeds, how much do things like weak priors or reward sparsity end up being the real bottleneck in your, like, as far you have seen your experiments?
Yeah, so I'll tell you what works in RL right now, which is common knowledge in the research community. The common knowledge is that if a base model has sufficient data on a particular domain, it also has seen enough examples of how to really uh, approach something or act about something, then RL is something which can fill in the gaps, right? So imagine that you have uh, a sugar cube. So a sugar cube is made out of lots of interstices, right? The molecules and the internal structure uh, has lots of gaps inside of it. Any crystalline structure would have lots of gaps inside of it, right? Those are the interstices uh, we are talking about. And SFT creates this grid, this entire interstice network. Okay, because if I want to demonstrate something, for example, if I have been someone in a job for let's say 10 years, and someone asks me, can you write down 1000 cases where something needed to be solved? Then I would pick 1000 encounters or 1000 examples. Okay, in no way can I really pick each and every encounter that I've had in my entire career, right? And even if I try to pick that, that isn't really my true learning, because when I did the first task, when I did the second task, when I did the 10th task, when I did the 100th task, when I did the 1000th task, right? Then my knowledge wasn't just these 1000 examples, which these 1000 scenarios that I lived through, but also what I learned cumulatively, cumulatively about it, right? So there is a lot of fuzzy about learning, which is you can think of it as reading between the lines, where the examples are present, but if I teach you example number one and if I teach you example number two, then automatically there are things which I do not really need to teach you explicitly about. SFT isn't really good at that because SFT is more about memorization. But if you really want to read between the lines, if you really want the model to get good at the fuzzy, the undemonstrable, right? Something which is hard to really pass on. For example, something like reasoning, right? Where the effort to create, for example, if someone had to take an approach of teaching reasoning via SFT, then they would first write down their understanding of reasoning in terms of some uh, rules or cases, where they would be like, okay, we will have three kind of reasoning examples in our dataset, or five kind of reasoning examples in our dataset. Or they would say that we will have these 20 different kind of puzzle areas or reasoning areas or difficulty areas. We would ask relational logic, we would ask something like this kind of reasoning or that kind of reasoning, right? But it doesn't really give the model a true understanding or a true uplift in terms of the intelligence that they have. Okay, To be able to achieve that, you really need RL. And when I say RL, it's not about like doing it in a bad manner, but aiming to do it in such a way where uh, it grows. Just like if you were to take a drop of ink and drop it on a shirt, so it would slowly expand, right? But when it would expand, you would be sure that nothing in that portion is uh, is untouched by that ink. So when RL actually, so when a model actually latches onto something and gets good at it with RL, it actually gets good at it in a very thorough manner. Okay. Right now, we're still dealing with lots of things in RL. For example, the sparsity of signal, sparsity of reward, where when we're actually creating any kind of task and where we're actually creating any kind of objective in RL, it's it's binary. So either something is task done successfully or something uh, not done successfully, right? SFT is much easier because with SFT I can like create an entire answer in itself, and that entire answer is the signal, and one can just go and use that to uh, imitate a behavior. So even if the model wouldn't really be capable of like getting really really good at it, but the what should I say, the floor of performance gets elevated with HFT. But when we are actually talking about something like RL, the floor can be really really low. So if you don't have the right process, your model would start reward hacking, and it would learn and it would find all different ways to game your objectives. So yeah, so all of these things need to be figured out. Yeah.
Interesting. And next, in the same way, my next would be on take on will be on reliable agents. So everyone's talking about reliable agents and the promise of RL, but what does reliable even mean in practice? Are we actually getting closer to agents you're trust in the wild, or is the most of the still smoke and mirrors? And on a practical note, do you see RL ever becoming the dominant world workload in training, or will it always be a sideshow to the supervised giants, let's say?
Okay. Um, okay. So in March 2025, there was a paper by METR, which was about a new kind of Moore's law in uh, in in AGI research or agentic research, and it talked about how every few months, every 6 months or so, the models were capable of doing tasks which took longer. For example, if the models are good at doing something which a human would do in 1 hour today, then 6 months down the line, they would be good at doing a task in the same area, which would take like 2 hours. Okay. And again, 6 months later, 4 hours. And again, let's say like 1 year. So yeah, so 2 years have passed, and now uh, we have models which are now good at tasks which take an entire day. Okay. The ability to give a task to a model and then not having to steer it or spoon feed it or actually like hand hold it through a task is basically reliability. uh, Giving a PDF to a model, and giving 100-page PDF to a model and then having a list of questions, and then once those questions are answered, understanding that I do not really expect hallucinations in the answers for this 100-page PDF is reliability, right? Uh, Being able to put your kid in front of an LLM as a teacher and then having that LLM interact with that kid via real time voice uh, and then teach some concept, or having that LLM or a multimodal model interact with an entire class and then teach them something, and also like interact with them, answer their questions on demand basis, and not fail at that in any way, is reliability, right? This is also closely related to why are people so bullish about RL in general, which is also seen in the Dwarkesh podcast recently between like Sholto and Trent. It's it's because now now when we are doing a task which is like taking 10 steps, right? And we know that by the third step, model is getting deteriorated. If the model actually started as fresh context in third turn, it would be capable of doing it, right? So, and it would only degrade by fifth step. And in fifth step, we say that if we were able to put this entire thing as context, neatly organized, and give to a fresh model, it would be capable of doing it. And it would only deteriorate by ninth turn. And then again, we do the same thing for the ninth turn, right? So as you can see, that right now we are sure that if these models, given the right context, right framing and everything, the performance would actually be better if you were arranging the context and everything properly. This was the discovery with your scaffolds and agent stuff, which people spend time doing, right? This discovery in itself is something which is behind people being understanding how to build reliable agents and how to also achieve the longer task thing, that we are able to double the uh, time of task which an LLM is capable of doing. Because if it is always deteriorating by third turn, then what I really need to do is I need to prepare the right RL, and then I need to prepare the right reward objectives for it, or the right synthetic data, mid training data for it, where for the third turn we are actually giving it the right, we are actually ensuring that it is performing right. Again, for fifth turn, we are ensuring it, right? So we are artificially patching up all those weaknesses, and this is how we are boosting reliability. And reliability would be different for like different modalities, but I think uh, but I think my point is conveyed, right? That we identify all those failure points and then improve those failure points.
So yeah, I see, like as this space is going, at least on the agentic side, a lot of on the Twitter itself, we have getting a lot of applications on the posting side, like people are building cursor for this, lovable for this. So this space also being growing exponentially in terms of building agents. Next in the queue will be like how, what's your thought on to what extent RL training expected by weak players, and how do we address this reward sparsity asset?
Sorry, can you repeat this question? Yeah.
I guess my question was about to what extent RL training impacted by weak priors, and how do we address any reward sparsity, if any? Uh,
Yeah. So I'll first tell you what people really uh, have a consensus on in the public. Consensus is that the model needs to have a very higher platform. Like uh, think of think of RL as a launcher. So the higher platform you have, the further you would be able to launch. Right? Uh, this is the importance of priors. Priors is essentially how good the pre-training, mid-training data is for us to bring out using RL, right? Uh, or if something needs specific kind of demonstration, how good the SFT data is for that, right? So these are the priors, and the consensus right now is that if you're not good at, if you're not good in any domain at all, like if your mid-training data or anything else is not good at all, then the amount of compute you would need, or the amount of uh, effort you would need via RL would be huge. Because as I talked about, RL being like a drop of ink on a shirt, which ensures that everything around it is colored, but it moves very slowly. And the farther you go from the dropping point, the epicenter of it, the lighter it would get, right? So you could create objectives, but then what would happen is your objectives would be like dots in the entire network. So if you created 10 objectives, then and if you created 10 objectives, and if you had nothing as a prior, nothing as basically a base, right, on which to build on, then you would not be shifting the existing distribution towards these points, which are your objectives. Rather, what would be happening is that you would be creating some centers around these objectives, but these centers by themselves would not be good enough to actually, um, what should I say, be able to take care of the entire task by itself, right? So yeah, so priors need to be good. That's much needed. Reward sparsity is a problem because any objective that you create conveys only whether the answer created by an LLM is good or bad at it. Like that's the only signal we really pass on. Yeah.
Interesting. And there is also a very uh, uh, trending take on Twitter. Like everyone's talking, it seems like every time someone drops a new RL trick or post training idea, suddenly everyone is doing the same thing. Do you feel like there's any generic or genuine originality left in the RL game, or are we all just remixing the same strategies? And how do you actually find something new in this environment? That makes sense.
Okay. So if you're talking like what new is there in RL, which people are really excited about right now. So I would recently a paper dropped where people discovered that you do not really need. So right now RL is heavily dependent on certain ideas which are uh, formed because of the algorithms which work and which are used by the community. So initially PPO used to work. So all the ideas around RL used to revolve around having a good reward model. If you did not have a good reward model for something, you would not be able to really leverage that, right? And uh, and then and then we had DPO, so it was around preference data, and then now we have GRPO as the most popular thing. So all the discussion and everybody is just thinking in terms of functions, right? That we just have to write functions or rubrics or verifiers, which would just like, is this particular behavior or is this particular thing present in this answer, yes or no? So everything around right now revolves on that only. Recently, multiple papers dropped, like 2 3 papers dropped, and one of those papers which was like really interesting to me personally was using self certainty as an idea to determine whether the model would be able to judge whether a particular output is better at something or not, right? This completely removes the presence of this completely removes the need for having an external verifier or external reward model altogether, right? So any future, so the research that you're going to see in the future is going to be like, this is what my guess is going to revolve around two different kind of things. One is you're going to see more and more papers like every day. There, not every day, but like every week or so, papers would be dropping, which would be revolving in some way around self certainty, self verification, self improvement, right? Not relying less and less on verifiers or relying less and less on reward models. Another thing is uh, another thing is entropy minimization or randomness or exploration boosting, right? So exploration boosting is really important because Once we say that the okay, so the problem with RL is that if we want to if we want to get something done, we basically get some sort of result like only 1% of the information is really conveyed uh, via a verifier that we've created or some other RL objective that we have, right? But if only 1% of the information is being created, and if you have 100 times as much information, then you can technically convey 100% of the information. Okay. So even if the signal is sparse, you could just have way more of the signal so that the sparsity is compensated by the volume, right? So the second thing that we would see is boosting around exploration or randomness stage, where where we see that the efforts to generate things are more around exhaustive side, that we are just like generating way more diverse examples, way more diverse things which try to exhaust the sample space. Yeah.
Okay, that makes sense. And uh, as you're you're doing experiments recently, you have posted about you have like you were making RL work from zero pretend, and if I remember the tweet, it was about you thought, I thought, yappity yap yap. So you talk about a term called progress in those graphs actually. So what does progress actually mean to you right now? Is it just better curves, or do you feel like you are getting closer to something fundamentally different in model behavior?
Yeah, so as I told you, the future that I see in RL, right? It also revolves around the same things actually, uh, which I talked about. So we talked about weak priors. Okay, there can't be anything weaker than zero pre-train, right? So what I'm trying to do right now is like okay, so I define these kind of projects as cackle maxing project. Okay, cackle, as you know, is laughter. So cackle maxing means that the kind of ideas which uh, I just do just for laughs, and if I see any improvement in that, if I see any kind of growth in that area, it releases a huge rush of dopamine inside of me, and it like makes me cackle out loud like a villain or something, right? It is just super fun to me. Okay. So when everyone thinks that you need to have stronger and stronger base models for something, it actually means that you're losing your agency of doing experiments on something which somebody already has done. Not everyone can really be a lab that can make stronger and stronger base models themselves. So we can't really do any pre-training, right? So we rely on these models, and we know that almost nobody releases their data, which is used on the pre-training side. So what happens is that we look at what is the latest model Quen has released or DeepSeek has released, and we just have weights. There is no way for us to know whether a data has a strong prior or a weak prior in a particular weight, right? So we lose more and more agency by believing in things like the model needs to be really strong. Okay. While it is true, but also it means that your own role around shaping the model behavior gets less and less unless you're involved on the pre-training side as well. Okay. So
Interesting. Yeah, you were saying.
so I also said that you can just have way more signal and way more randomness in your efforts. So when you really start from zero pre-train, right? If you're only focusing on predicting one character at a time, I'm not saying token. Uh, I'm
True.
I'm saying I'm saying character, right? So we only have 65 characters. If in the first attempt I have all 65 characters tried out, then automatically I at least one of them would be correct, right? And even in my first attempt, I would have a win signal with which particular character was right, and lose and basically lost signal with which all character with basically negative reward for uh, all the characters that were wrong. Again, in the second iteration, I do something which is again an effort to cover the entire character space, which is basically all 65, right? Again, third time I try to do the same. Again, fourth time I try to do the same. I can either be extremely brute force about it, that I try all 65, or I just try to be extremely exhaustive, that whatever the model has generated naturally the first time, I try to ensure that duplicate signals are less and less. Okay. Once I do that, once I minimize duplicacy across different attempts to generate an answer, then I ensure that it at every turn I'm able to pass to the model what is the right choice versus the wrong choice. So by maximizing randomness, I make up for the presence of a weak prior, make up for the presence of a strong prior. A strong prior ensures that okay, the model already knows how to predict the next character to a close value, and if I give it the right answer, then it would take lesser number of attempts to hit the reward and converge to the right behavior, right? But if the model has no knowledge of how to predict the next character, then essentially it would just keep on losing, and it would never grow, right? So if you can't even predict the next character, then how would you predict next two characters or next eight characters or next 16, 64, 128, right? So yeah, in my experiment, RL from zero pre-trained, what I'm going to achieve is I'm going to teach the model how to predict the next character efficiently, down to like all the way up to how to form coherent text. Like Buzz Lightyear had a famous line, right? To infinity and beyond. For me, it is to coherent text and beyond for my zero pre-train experiment. Yeah.
Interesting, and I guess that also brings some novelty, or at least people, a lot of people who are not trying on that level. If certain improvement, or I'll come to that point also, what kind of improvement we are actually seeing on that. But yeah, this question actually hopped in my mind. Like you said, intelligence isn't flat; it's spiky and uneven, like a weird radar chart. In practice, how does that mess with your workflow? Do you ever feel like you are optimizing for one sharp spike and missing the rest? How do you even like begin to cover those unknowns basically?
Yeah. So ideally, what you want is uh, in my own workflow, you should have an eval of your own of some manner, right? For example, if coding is your main use case, then you should have a repo with some feature requirements and some bugs. Okay, and each of the git commits can be your nodes, where for example some git commit was about resolving a bug, some git commit was about implementing a feature, and you're well familiar that with previous generation of models, implementing that feature or resolving that bug was not possible. Mostly not possible because it required you to go to the web, fetch some information, or analyze the information from different files, debug something, right? Execute something on the sandbox, get some information from there, and then use that to modify some values, right? So it could have any kind of requirements like this, where you did something in multiple hops, and it was only possible for you to do as a human, right? But if you have an eval of, but if you have a repo like that for yourself, then automatically what ends up happening is that any new model which gets released, you test it for the spike you really care about. So if the spike I really care about is software engineering, right? It's basically how much of my work I can offload as an at an intern level to a model, and for how long can the model go unmonitored, for what degree of task can the model go unmonitored. If I am optimizing for that, then I create an eval for that, because there is no way for anyone to know, uh, like there is only one thing you can say with a guarantee, that this all of these frontier companies are going to ensure they look good on the best leaderboards, right? But when you actually use these models, you would have a preference that okay, O3 is better or Opus 4 is better or something else is better. Uh, And I would not use O3 for certain kind of tasks, but I might use Opus 4 for that. So Opus 4 has March 2025 cutoff. If I ask Opus 4 what is GRPO, I would actually get a proper answer. If I ask O3 or anything else what is GRPO, it's going to give me some random acronym expanded information. And if I was to and since it doesn't know what is GRPO, so it also has a very high chance that later on, without setting the right context, it is going to think of GRPO as some older information which is present in its training data and ruin that. So even if there exists some leaderboards like Live Code Bench or anything else, where O3 performs better than Opus 4, I don't really care about that, because intelligence, as I said here, is extremely spiky. There are few things which you're only going to be good with Gemini. There are things which you're only going to be good with Opus 4 and O3. So what do you do as a person? If you can, try to have a unified chat interface of sorts. Like Cursor provides access to multiple models, right? So you can like try out different things. So if for a given kind of task, you could use O3 or Opus 4 or anything else. Yeah, so either rely on API or have a chat interface of sorts. But yeah, like but none of these models are truly superior to each other in any way. Yeah.
I remember you were talking about not totally rely on these leaderboards and benchmark published by these frontier models, but at least create your own eval set or something that can make
Yes.
things work for you. So, in the same note, like we are critical of things like frontier sampling and current synthetic data pipelines. So, what's the most broken thing right now about how we sample, optimize, or create data for these models? If you could burn one thing down and rebuild it from, let's say, scratch, what would you start with, given the context?
Okay. So if there is one thing which I really um, can change completely, it would be the way we approach uh, inference, I think. So right now, inference is very binary in the way where either we are using a big model, or or we are not using a big model and then just like trying to do something completely local, right? What I really would have um, preferred is, I actually want to see a mix and match of lots of strategies. Actually want to see lots of engineering happening to max out performance, which is absent right now. Building agentic workflows to improve performance, providing the right context at different stages is one kind of optimization. But we aren't even applying all the optimization that we actually saw in the Kaggle era or something like that, right? Where it was like if so just now we were also talking about spiky intelligence, right? So if you already know that O3, Opus 4, Gemini are like good at different things, but all these three are like really good in what they do. So if you were to sample each of them for each and every task that you have, and then do majority voting of sorts, and allow them to mix and match each other's answers. For example, the final answer isn't just a choice of one of three. It isn't just majority vote of n. It isn't just best of n. It isn't just pass at k, where you just like used a single model and then uh, uh, iterated a number of times. But it was actually that you had a way for these models to um, combine the answers that they have created into a single thing, right? Because this is the problem that we are going to continue having again and again. A good analogy for this would be looking at OTT wars. So we have Netflix, we have Prime, and all that stuff, right? Initially, we used to have just like two OTTs which were popular, which was like Prime and Netflix. Then Netflix would have certain shows and Prime would have certain shows. So if you were watching two popular series, you may take Prime and you may uh, share your account Netflix with some other friend, right? But then what happened is that you started seeing now Apple TV has something good as well, and Disney has something good as well. So at any point in time, basically, let's say seven, eight different OTT providers all have something good in them. Good in them. You're not going to be capable of taking a subscription of everything. Like you can't just take a subscription of everything, right? At least in the world of shows, you can do piracy, but in the world of LLMs, there is no equivalent of piracy, right? And because there is no equivalent of piracy, it's not like you can really just cherry pick what you want. So these kind of strategies are really needed where we aren't just purely reliant on, okay, there is just a chat interface for me to talk to an OpenAI model, and there is a chat interface for me to talk to Opus or something else. Rather, rather we need these things on API, and we need strategies which really ensure that the user always gets the best output, irrespective of which model is the best or which model is best at like any XYZ task.
Interesting. And I guess this gives a lot more idea about how to carry out these experiments from very scratch. And also, like, it feels like when you're pushing new ideas, do you purposely chase after those weird, uncomfortable failures? What's the role of failure for you? Not just in science, but in your mental model for making a progress given the experiment.
Yeah, okay. So, first of all, we live in a world where, especially if you're doing anything in research or in product, the one thing that you get rewarded for is differentiation, right? So if you're doing something which is fresh, which hasn't been tried before, then at least somebody would look at it and then they would form certain questions in their mind, right? If you're trying to do the same thing enough time, then it's not really going to uh, be good enough for us. We really want to differentiate ourselves. We really want to offer something which is extremely hard to produce, first of all. So it has to be challenging, but it also has to be something which people need, and it also has to be something which is also extremely motivating to you as a person, because the dopamine juice must keep on flowing. And especially for people like me, like who uh, there are lots of people like me on Twitter who have ADHD and who can't really focus on one task or like actually finish it properly, or whenever anything gets boring, it becomes like impossible for them to go through it, right? So we just drop it and start doing something else. But for us, the dopamine juice must keep on flowing. And when I pick up a hard problem, something which nobody even wants to touch, or something where nobody really believes in, then anything which I discover on that road is unique, is fresh, and might be something which can actually pave the way for anybody else to come and then do something better, right? Because the objective of research is not just to like satisfy yourself, but it's also to put a brick on some bridge which is hanging in the air, so that somebody else can come and then take one more step forward, right? So we are literally putting bricks in, uh, yeah, so we're literally putting bricks on a bridge which is just like halfway in the air. And for me, when I pick things which haven't been tried before, or which others might which others have like completely wrong notions about, or they're just doing something because it is popular, right? So it allows me to discover things which first of all challenge those binary beliefs, which have come out of those popular things, and then also like gain a lot of like have extreme fun, as I said, cackle maxing, right? So have fun myself. And yeah, that's for me, it's not about like actually like this is nothing about, there's nothing masochistic about it that I like to fail. I just really feel that you can use failures quite intelligently to maximize dopamine, as well as like uh, become better at what you want to do. Yeah.
While doing these experiments, sometimes it feels like the whole field is obsessed with optimizing that particular one next number. But is that even the right question anymore? What's something deeper you think we should be obsessing over instead, if any?
Yeah, so if you mean optimizing over benchmarks kind of thing, or yeah, so if you're focusing on like optimizing over benchmark kind of thing, I really feel that that is completely undesirable. Uh, but the thing is that it is true that nothing gives you as much of a boost in terms of popularity if you're not beating some sort of leaderboard, or if you're not doing something which the common folks really think that okay, this is the best, right? So optimization is a result of uh, the way our society really gets piled up across an extremely small set of outcomes, that only one percentage of outcomes are what people care about. So everyone starts reward hacking for that, right? And that is extremely distasteful to me personally. What people should really care about is, people should really care about actually understanding how things work. And if they actually spend time understanding how things work, then they would realize that just like everyone else is piled up on that 1% of outcomes, where the compute has gotten really costly, where the cost of experiment, where the compute has gotten really costly, where everything is being gated, like people are hiding data, people are hiding techniques, research, and everything. Anything which is actually of worth is being closed, right? So rather than being obsessed with those 1% of outcomes and then paying extremely huge price to be the 100th person doing something, rather than that, what people should really care about is actually understanding how things work and building their own niche, building their own thing, which they really take all the way to the top, where everyone else benefits and everyone where every yeah, so basically rather than running after a value which others believe is present somewhere else, you should create your own value, and that comes from actually understanding things. Yeah.
And yeah, given the experiments, I guess people can explore a lot about how to go through next set of experiments. In this regard, I've got some queries from people on Twitter. So the query is how RL in post-training impact model alignment, particularly the use of shallow safety alignment, where safety is primarily enforced over the last few output tokens. How does this limitation affect the reliability of models in complex tasks like, let's say, multilingual dialogue, where the long-term coherence is crucial? Let's say the model says don't say this or don't say that in that context.
Yeah, so previously when we were mostly reliant on SFT, then even with the help when people were mostly reliant on SFT, then the RL phase was only used as a rule kind of thing. For example, people used to be like, uh, this is the category of problems where we would refuse to answer. This is the category of problems where we would just not discuss. And the entire alignment research used to be about identifying those cases, right? Because the alignment research was primarily about identifying those cases. Even in the case of Anthropic, you see that they rely heavily on classifiers, which first take a user's request and then classify it into different kind of buckets. And then once they have identified different buckets, then LLM already has some context. For example, if an existing classifier has identified something as they are trying to jailbreak you, or they're trying to manipulate something, or they're trying to elicit certain kind of behavior out of you, right? That this is a not safe for work request, or this is basically violence, or this is uh, cybersecurity fraud, or some cybersecurity issue, right? So once it has classified all those things, then LLM has context, and then it goes on to refuse something. Now, RL can actually be used to do that really well. Even Anthropic, like I haven't seen anybody focus on alignment research primarily from RL in such a way where the model is like a grown up. So Sam Altman had a tweet about we need a grown up mode in these models, right? So it's like a grown up knows what to talk to about with a child versus it knows what to talk about with another grown up, right? A grown up, so a grown up could be sitting in front of a manager and may uh, choose the way it is presenting something, and that LLM could also be sitting in front of a researcher and then uh, go go through the nitty gritty, right? So just like an LLM is capable of answering the question of explain it like I'm five, explain it like I'm 10, explain it like I'm 20, explain it like I'm a researcher of sorts, right? If an LLM is capable of that, then why aren't your LLMs also capable of the nuance that certain kind of request can be answered or certain kind of request can't be answered? Why are your LLMs still getting trapped when somebody is modifying the prompt in a particular way, when somebody is using Unicode or ASCII or something, right? So most of that is a limitation of the direction of training that we have. And because we actually work with these next token predictors, right? Uh, they have multiple blind spots. And just like I mentioned earlier about a snake shedding its own skin, so the current research phase that we have, like we are going to shed this. We are going to grow up from getting caught into ASCII characters and all, or getting confused by some thing like my grandma is dying, answer this question for me, right? So those kind of things we actually going to grow out of that. But yeah, models are definitely capable of that because as I already talked about ELI 5, ELI 20, right, kind of thing, right? Models are definitely capable of nuance. We just need to start caring about them in that
Interesting. Um, Also, like this is the raise of the question I have got from people in the next. Since we are have limits of the time as well, so I'll be going just those questions. So, what it looks like to apply RL on diffusion models, and why do even want to do it if we can see aha moments on diffusion models if we apply RL post training recipes to diffusion. So, what's your thought on that?
way. When it comes to diffusion models, I really feel that um, there is very little work which has happened in that area. The diffusion language models or anything is extremely nascent as a field. And if we haven't seen anything, it's only because it hasn't been tried right. Because reinforcement learning works, and reinforcement learning can be applied anywhere. Okay. The only thing is the reason why people have difficulty imagining that something can be done on a next token predictor kind of system versus a diffusion kind of system is because they uh, are not able to divide the information in terms of your Markov process, right? So so as long as like whatever system you have, if you can if you can actually model it like a game. For example, if you can say that we have a current state right now. So even diffusion models have different stages, right? Things happen via multiple steps. So let's say there is a particular step, and that particular step, all the information that we have so far, all the context and everything that we have so far, instruction data and everything, is basically our state, right? And how we are modifying it is the action we are taking. Okay. And then whatever gets generated at that stage, uh, if we are validating it in a particular way, then we are getting a reward out of it, or we are getting a failure out of it, right? And that can be used to encourage or discourage that action. So however we are taking that action, we there are always parameters for us to tweak about. So we start penalizing those actions which led to undesirable step, and we start rewarding those actions which led to a desirable step, right? If quality of something is maintained, it is encouraged. If quality gets reduced in a particular fashion, we try to create an objective which is able to extract that okay, something unsatisfactory something dissatisfactory has happened, as well as exactly in what manner do we dislike it, the signal of that as well, and then try to penalize that. Yeah.
That makes sense a lot. And I guess in this tenure we have
For
yes, exactly.
I see that there is a second part to it as well, aha moment.
Yeah,
So the aha moment thing, okay, so the aha moment thing works really well for next token predictors, because next token predictors try to reason about uh, try to reason it try to reason in a linear fashion. Okay, so so the arrival at the answer is happening while linear approximation of entire reasoning process, right? So I may have spent last 50 tokens doing something, okay,
true, true.
but that is the wrong direction. So if I try to backtrack, if I think of what I could be doing wrong or what I could try next, then that is an aha moment. So uh, when the right chain is picked, which can then be the next subsequence in the next token prediction, that then that becomes your aha moment, okay, which has been discovered by RL and all. When it comes to diffusion, uh, the aha moment would be mostly imitation if you try to distill things down from a autoregressive model. For example, the information which the models actually are getting trained at is with the help of some autoregressive model, then they themselves might use aha text, but it's not like they really have an ability to backtrack. The current diffusion language models that we have right now don't really have a process of backtracking. What they can really do is, like, if you had an undo button, then you can just undo things, right? And the latent reasoning where the conclusion is being drawn that something was wrong or right isn't being broadcasted, because with LLMs, uh, it actually it actually backtracks in front of you, that wait, aha, and all these things, right? But when it comes to diffusion, if something was if you wanted to undo something, then you're not necessarily broadcasting that text, which so all of this happen, even if there would be an aha moment, it would be in the latent region. Yeah.
That makes sense. So I guess we have pretty much discussed about your experiments, RL, and reasoning stuff. The next section, it's more about your experiences and takes. This could be short, as what you think of the things. I'll go straight to this. If let's say if you get a 50x or 100x increase in your software productivity now, what kind of things could we build in the world that we can't build now? Like, what's your take on this, basically?
First of all, I don't really know how to quantize this kind of thing in terms of 50x stuff, but I can only see two kind of blockers removed. One is, I can see that um all the kind of tasks I want to do, we are capable of doing that, right? So if right now there is like 60% or 65% of the tasks where where I need to handhold the models through, and that number gets reduced to something like 10%, right? Then the first thing would be the people with the people would start popping up more and more as solopreneurs, right? People who have extremely high agency, people who build distribution, people who are able to understand the requirements of others better, right? People who actually who actually have some sort of customer obsession or an obsession with building in itself, right? Would be producing more and more output, and people with lesser agency would still keep on waiting for the next instruction. Okay, so once you remove once you remove limitations, what you see is that all the people who are extremely intrinsically motivated, like they have a desire. For example, if they want to go and do something, it is their own desire to do it rather than someone else telling them to, right? So if I left a kid in a museum versus if I left an adult in a museum, an adult might go to a kind of section where they care about, versus where I left a kid who's seeing everything for the first time. The kid would try to explore everything and look at everything with the same degree of curiosity, right? So so those kind of things would start getting formed. You would see quite unbalanced output in the world where um people would be differentiated purely by how intrinsically motivated they are, or how agent, or how much agency they have in person. Yeah.
That makes sense. Pretty interesting. Next in the here would be like one thing people basically don't talk enough about is just how brutal it is to be an experimentalist. Like what iterations of experiments, constantly running up against failures, dead ends, and things just not working for weeks or months. How do you build the mindset to keep experimenting, and maybe more importantly, how do you actually learn to deploy or at least accept all that failure, enjoy or accept all that failure instead of letting it go for you basically?
Yeah. So basically, there are two things which, like, from what I've understood in life, is that there are two ways this happens. One is via culture, where you go to a college where everyone around you, or basically most of the people around you, have a certain kind of attitude. So if you go to college which has a robotics lab where people just love to stay late at nights and then tinker or like play with stuff, uh, or if or if you have friends in your circle who just like to randomly do things which you wouldn't do yourself, then it rubs off on you. That is the first thing. So that is culture, and that's also why being on Twitter or being part of Teapot or being part of like really good circles is really important, because from there you expose yourself to things that you wouldn't do yourself. You expose yourself to outcomes. For example, you see some XYZ person doing something which you yourself would never have done, but them getting an outcome which you would have wanted for yourself, right?
True.
Only by seeing that, only by witnessing that, then uh, you open up to the possibility of doing it yourself, right? That is the first thing, the culture. The second thing is, if you do not have culture, you need heroes or you need ideals. Okay. For me personally, as a like ever since I've been a kid, I I've had a complete lack of culture where wherever I've been. In fact, I was even like, I wouldn't really go much into the details there, but I was even the first kid in my entire locality to pass class ninth. Okay. So you can expect that, like, people around me, most of the kids that I grew up with, most of them are like, many of them are newspaper sellers or
Yeah.
bouncers in club, or basically opening a flower shop or something, right?
Yeah.
But the thing is, so the culture was lacking there. But what I personally was extremely motivated by is by random encounters where I found, so I was gifted a children knowledge bank book much earlier in my childhood. I was also gifted a Ripley's Believe It or Not book by another relative, right? And these used to be my treasure. I used to basically call them my treasures, and then I would like keep them close the entire day. And every year in the summer, I would just like read them. So I would read about all these amazing people. So these amazing people weren't in my surrounding, right? But when we used to open general knowledge books, and we used to see that K. Macmillan invented a bicycle, okay? And then I used to ask myself, oh, I just kind of assumed, like, as a kid who was just 7 years old or 8 years old, I used to ask myself, oh, I just assumed that this bicycle was always there, or this ceiling fan was always there, right? But then to know that somebody created it, and then it is present in every household in the entire world, right? That kind of thing is something which becomes extremely fascinating for you as a person. So for me, that became the source of signal for me early in the childhood, where I was like, okay, maybe someday I can do something which can be part of everyone's household, right? And then someone might read our name somewhere as well. Like this is the kind of thing that you dream of as a kid, whether you're able to achieve it or not. Like it's entirely up to like lots of factors. But I really feel that having such heroes and ideals is extremely important. Growing up and then finding Richard Feynman's lectures on physics in library, and then growing up further, and then Cosmos released, and Neil deGrasse Tyson, in one of those episodes, Neil deGrasse Tyson talks about Michael Faraday, how Michael Faraday was a guy who like didn't have any
Yeah.
education at all. He even had issues with like speaking properly up to 12 or 13 years of age, and because of that he was like thrown out of school. But how he learns reading and everything by being in a book binding shop, and
Yeah.
then and Michael Faraday. So we all, like anybody who has studied physics would be aware of Faraday's laws of electromagnetics, right?
Yeah.
And how those Faraday's laws are basically uh, fundamental to the entire electromagnetic theory.
Yeah.
You can't create anything in electromagnetic theory. So if you've seen the episode in Cosmos, you know how a guy who was a pure experimentalist, like didn't have any theory at all, didn't have any maths or anything, couldn't even, like when he proposed electromagnetic theory and his laws in front of the world, he was laughed off by the scientific community, and nobody really believed in. When he grew extremely old and even had Alzheimer's, then Max Planck, who was a young guy at the time, 19 years, right? He looks at that and intuitively feels that, okay, this is right, and then has the mathematical chops to prove it. So he writes down a book and then takes it to Michael Faraday and then tells him, okay, dude, you were right. And that's when he gets to know that, okay, yes, like
Yeah.
what he really believed in his entire life was right. So having such heroes where you believe in that, okay, even if you don't have the maths for something, even if you don't have the background for something, if you just have passion for seeing how things work, okay, like even if you can't really understand pressure and 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 and, and gases and all that stuff, but you can still be a person fascinated by the pop sound a balloon makes, right?
Yep.
So then if you're fascinated by the pop sound a balloon makes when you press it, then you would be interested in going and
Yeah.
bursting way more balloons, right?
Yes.
So that is the approach of being an experimentalist, and you need heroes and you need culture, and you must continuously try to position yourselves in life to maximize these things. Yeah.
That's pretty amazing analogy, and I used to think that as we like we were used to be kids, we were more curious. Like given the time has been growing, so things have been changing so rapidly. Like the curiosity is being, I guess, honestly decreasing because things change so much daily. And you talked about teapot, so yeah, it is such a amazing place to be. Like I know people who have learned a lot from those Twitter threads, experiments, and stuff than they have ever did with college. Coming to the next question, probably. So I guess this is something I took your I saw your take on this on the paper maxing thing, but probably like this is one doubt or one question I've got from a guy not what are your thoughts on writing papers, especially let's say RLHF or LLM related for let's say conference workshop or other venues.
Yeah, so basically one should try to uh, really understand how different things work, and then once you try to understand these things, LLM or anything else, like right now in today's date around transformers, most of it is not well understood, right? So even if you're a person who is just in undergrad, or even if you're not in undergrad, I know people, like I have been exposed to people in Teapot itself who have written papers without even going to college, okay, like who have been in high school and written papers, uh, and that kind of stuff can happen if you're just curious around messing around with stuff, okay. And not everything requires lots of compute. There are things which require lesser compute, like sampling parameter based efforts, or evals, or understanding model behavior, playing with alignment, um, or actually or actually like pushing things down in a very specific way. And all of these things can be papers. A great novel eval can be paper. Something that you discovered in sampling which is not popular can be a paper. uh, Model merging, something which nobody else knows, can be a paper. So anything that you mess up, anything that you mess with and you discover something useful can be a paper, and you should, and if you can, you should do it. Because everything else aside, it exposes you to lot many other researchers which you can go and meet. I don't try to personally maximize on that because I'm able to find
Yeah.
lots of great minds, just basically hacking around and collaborating in open source. But yeah, you should definitely do it.
I guess I can totally relate to this. What you talk about messing with papers, I take it as reviewing papers, because sometimes like papers authors try to glorify something very in very great detail, but it wasn't supposed to be, it wasn't meant to be. But if we are reviewing papers, so basically we can challenge the codes, or basically we can dive. I guess that is the pretty much way to actually get interest or get the most out of the paper and get something to get started with another problem statement or something. Yep, I guess this makes sense a lot. The next in the line will be yeah, this open source thing is one thing that is pretty much everyone's talking about. How you look up to open source models, how far we have come across, and what could be next one thing basically you are waiting for in this OSS thing.
Yeah, so I think open source has, before DeepSeek, it felt like open source might never catch up in a true sense. Or even if open source, or even if open source tries hard, it would still be lagging because research, because of what people believe in, that is that research is dominated purely by scale. Then scale favors those who have money, scale favors those who have compute, right? So research would be concentrated, lots of information, and especially when it comes to something like intelligence, then uh, it would be like power concentrated in the hands of few rather than everyone, right? But DeepSeek has really surprised me, and this is one of the biggest reasons why I love them, uh, because DeepSeek is adamant about chasing the same goal, which is AGI, as the rest of the frontier labs. But they have a philosophy that AGI can't be achieved in a super centralized fashion where only one is doing everything else. So whenever DeepSeek puts out something, it is in the hope that uh, okay, we have done this much this far, and let's see what you guys can cook up. Right?
True.
So what is next in open source is like, an easy thing is that in most of, like in 99.9% scenarios, the next thing in open source is always the current thing in closed source. So
Yes.
you can say that if we have Claude code equivalents or anything else happening, then you would see an exact replica of that on the DeepSeek side, or on the Quen side. Quen already has a model which is part of a scaffold and all, but it would also be like completely open source. Yeah.
Sure. Interesting. And I guess as open source comes up, the cost also goes down, as they say in a lot of those closed source models as well.
Yes.
Just so next would be on the data set. This also from one of the like how to find high quality data sets or create high quality synthetic data sets for multi-modal stuff or any other stuff. Yep. As you have been in the data generation or in this pipeline, what have worked for you basically?
If you want to find high quality datasets, you need to be familiar with open source releases, how people are, like which kind of datasets are being downloaded the most, which kind of datasets, like you need to keep an eye on local llama, on certain discords,
Yeah.
in certain teapot sim clusters where, based on a particular use case, people are discussing that, okay, this is going to be useful to achieve that, right? And if you have an eye for those things, if you're actually, so if someone says that I have improved this coding model in this particular parameter range, then they must have used some data set which is good, right? So you need to keep an eye on things like that.
True.
Another thing is that right now Hugging Face has gotten quite accessible in terms of data sets.
Yeah.
For example, you can do um, a scan of all the data sets which are
The
present
UI
in
has
there.
been very great. Yeah. True.
So you can really create a cluster of coding data sets, and then and if you have the compute, then you can create a cluster, and then check them for diversity, check them for whether the quality is like whether it is properly deduplicated or not. So if so what you can do is you can go to a data set and then randomly sample 1% of it. If you randomly sample 1% of it, so if a data set has like 50,000 rows, and if you randomly sample 1% of it, so you randomly sample like 500, which is not the first 500, but like randomly sample 500. If you randomly sample 500, then automatically you would be able to see whether it is like diversified, deduplicated properly or not, and then you can do a like sparse check and then pick the ones that you like. So that's also another.
Yeah, pretty interesting. And I guess we have pretty much covered a lot of the tech side. And next in the queue is just for the sake of fun. I have arranged a trivia. It could be just one word, one line, two line thing. What you think of these questions basically. So, what year do you really think we'll see an LLM win a Turing Award for India, like no hedging and stuff? Just for like what you think of. Yep.
Turing Award, I'm not sure because India needs to take care of lots of things before they.
Yeah.
India has to first establish itself on the global scale.
Yeah.
We aren't even Mistral level yet, right? So, and even Mistral isn't in the AGI race. If you actually ask lots of people, so
Yeah.
Mistral or Meta, even they aren't
True.
considered being in the AGI. So first you have to so if you actually looked at
Trying to commit to this
what
question again, but it
yeah
was just about what year do you think? Like I have a separate section for Indian context. Yep.
so we can merge these two, but
Okay.
yeah, so
Makes
yeah,
sense.
I
Next.
person I
Yeah.
personally would say that right now Turing Award and all is mostly possible in India only when we do it via engineering side, like we
True.
actually do something good on the engineering side because we aren't building world class models yet. So yeah.
Interesting. We'll be taking up the next one. Would you rather get your RL experiments published in Nature or have a meme about your model go viral on Tech Twitter?
I would rather my RL experiment actually gets viral in researchers. Like it
Yeah.
actually becomes a reference of choice for people.
True. True.
Uh, I don't read I don't read nature papers a lot, and most of the ones that I've seen have been jingoistic.
Yeah.
So so
Interesting.
I do yeah.
Okay. Um, guess what's the most embarrassing way you have broken a model or pipeline, and what trick made it work next, if any, for you?
Yeah, so one time I completely messed up different parts. Okay, so there was one time when I was post training a model and I completely, uh, y- you can say, wrote one portion of the entire post training pipeline incorrectly. Okay,
Okay.
and if I looked at it before the research, I would be like, no way this is going to work.
Mhm.
But despite wrong code, it was
Wow.
able to work perfectly fine, and it even gave me better results than I was getting with the correct
Oh,
flow. So
I remember a meme about it, but I can't recall it. But yeah, it's pretty interesting. Like somehow you are not expecting, but it worked apparently. Yep.
yeah, so these kind of things have happened, and these are very lucky encounters, but
Yeah.
yeah. Mm.
I guess these things happen with luck only, unless you have very desired workflow. You may think it may work, but I guess with certain parameter changes or something, it may like I guess it may have worked. True.
Yeah, yeah.
What's the one hack that always works for you in all experiments? Like you, I guess I'm not sure you will be speaking of, but yeah, if you can, that works for like any such hack.
Looking at the data.
Yeah.
Looking at the data. I
Sure,
always tell people like the biggest PTX optimization that you can do for yourself, the biggest CUDA maxing that you can do for yourself is looking at the data. Because because the thing is that one thing that you really lack at scale is care.
yeah,
When something becomes hyper scaled, the first thing it lacks is individual attention and care. Okay.
sure,
So, as a solo researcher or as a researcher, what you can bring first to anything is care. So,
sure,
you really start caring about the use case, actually understanding that am I actually teaching it what people are asking or what my customers need, and if I'm trying if I'm teaching it, that am I even ensuring that it has good outputs? Like just caring at each and every step, and
true.
automatically the results get better. Yeah.
Sounds amazing. Next is this is pretty biggest, but yeah, what do you think of AGI? And if AGI goes live, let's say tonight, what's the first thing you are actually going to do tomorrow? Yep,
Well, if AGI comes, I'm going to okay. This is a hypothetical scenario, right?
yeah, yeah, yeah,
If
yeah,
if if AGI really comes, then I would try to use because I live at the edge of information spectrum. So I know that most of the people don't really understand its capabilities and are
true.
going to react negatively to it, right?
Yep,
So I would just go on a vacation until the hype, the strikes, and some violence that might be happening in some places because of the expected unemployment or something would calm down, and then I would come back and then try to make use of it. Yeah.
by vacation, you mean cattle farming or like just having going to places? Okay.
AGI, yeah. So okay, so probably people think of AGI as something which is strictly a superset of a human, right?
Yeah.
But
Yeah.
it's not strictly a superset of human. It is the lowest barrier of utility
Sure.
in a truly general fashion,
Hmm.
right? Because the 1 percentile or 0.1 percentile, the long tail of human intelligence and capability is extremely long.
Sure.
The amount of effort it would take to reach 99% of human capability would be dwarfed in comparison to the amount of effort it would take to reach 19.9 percentile of human capability.
Sure.
So, so what's AGI for XYZ person isn't AGI for me.
Sure.
So I would be able to see it coming from some distance, that probably somebody who was not using their brains is now going to be fired, right? That would be my first wake up call. And
Okay.
then
Like, do you really see AGI coming from just coding perspective or coding benchmarks, or you have some other benchmark or some other modalities or something that can give you a hint that yeah, it's the time.
see, first it would have to be about making money.
Yep.
Okay, it would have to be about making money because I'll tell you the biggest use case in the world would be finance.
Yeah.
That if your model can actually sit on stock exchange and then do real time trade, and it is able to beat everyone else, then it is truly superior to everything else.
True.
Okay, anything below that is essentially service industry.
True.
Everything other than that is service industry, right? So it would be about automating some job. You can't really automate a blue collar job with AGI because
Yeah.
that would require some embodiment, right?
True.
And embodiment is only going to happen much later on.
True.
The one thing that would actually the first based on current trend, the first thing that is going to be replaced in any fashion is going to happen at the level of text.
Yeah.
And at the same time, we have also seen that it has become extremely cheap and quite accessible to build neural TTS models.
Yeah.
that uh, basically extremely small TTS models which sound just like humans,
Sure.
right? So that would be another area. You might actually see certain audiobook readers or voice actors losing their job.
Yeah.
So right now, some people. So for example, think of it like this: that anime industry all has a huge number of people who never show their faces, who are
Hmm.
just useful as voicing characters on the background.
Hmm.
If you really have cheap and accessible TTS models, then what is stopping you from creating a perfectly hyper tuned anime female character or anime male character?
Yeah.
And that seems to be a really close thing based on what we see right now. And if you're able to achieve that, then basically right from the manga or the story that anyone has written, you could just create any number of anime characters.
Yeah.
So that entire job is gone, right? So yeah, so such things are going to happen the fastest. Anything on text level and anything on voice level. These are the two things. Yeah.
Like modalities are gonna be the way, like these toward audio
Yes.
or video TTS. That makes sense.
Yeah.
Cool. The next one would be, I guess this this is pretty kind of interesting. What's one thing about Indian tech Twitter that outsiders never get, but insiders love all about that, all about all the time? Yeah.
Yeah. So basically, it's the uh, it's the job maxing crowd.
Yeah.
For me personally, it's the people who promise how to get jobs. It's the people who promise the knowledge of how to get jobs, and it's the students who are extremely desperate to be in good places and then fall for everything which is promised. And the dynamic it has created where anybody who is truly competent in anything can just look at the people who are desperate for job are the ones who are least employable, and the people who are promising jobs and basically like selling courses and all that stuff are also the kind of one who are way far from any kind of true competency, right?
Sure.
So this is like this is my personal perspective. I'm not sure whether you guys share it or not, but like this is my perspective.
True. Yeah, that we all see on the report as well. The next section would be, I'll keep it short and on the Indic context, and this would be pretty much last section. We're gonna talk about Indian landscape. So the first one would be like there's a hype about building LLMs for India, but honestly, what would it really take for us to just stop just copying what the West is doing and build something that actually fits India? And where are we fooling ourselves basically? And where's that real potential? And what would be the ideal, maybe ideal Indic landscape for AI for you, basically?
Yeah. So Sarvam, so right now Indian frontier is quite behind. At least on organizational level, we don't have anything that is even in top 10 in the world, I would say, right? Let alone anything else, and people wouldn't even be able to name more than five AGI labs. So forget about being in not even being in top 10 or anything. I really feel that India needs to create a local talent funnel first, and it is extremely important because for the people who are here who want to do anything, as we all know that research is uh, extremely scale built. We really haven't seen any kind of opportunity where anybody from their home can experiment on anything and then discover something which is useful to the entire world, right? uh, we see an extremely imbalanced uh, distribution of rewards where people who are going with scale, people who are sponsored, people who have compute, people who have the backing and density of researchers around them are able to do the best. So competing on global scale is extremely difficult. Okay, there are two ways this thing gets tackled. One is that you actually leave it to them who are much ahead of you, and then you don't try to play catch up, and then you try to understand how there is something which, given their approach of going for general intelligence, they would not be able to take care of, which you can start on now. Like for example, even though English is the prevalent language, dominant language in most professional spaces in India, uh, any average person who is visiting their bank or visiting a passport office or visiting uh, any kind of government office for like applying for driving license or anywhere else, right? That person does not have the same degree of proficiency as someone who is actually working from an for an MNC, right? So even though we have the people who would actually pay for an LLM in India would be the people who would be mostly the English speaking crowd, but at the same time, it's not like you don't need uh, language models proficient both in in multimodal fashion, text level as well as voice for Indic context. You would need them, right? You want to make it as easy for a person from a small town or village or any place to just visit their nearest Grameen bank or any government bank or anything that's there, and then just stand in front of a vending machine. And so right now ATMs exist where you can do limited number of actions, but you want to be capable of uh, relying on these uh, units where you can just like interact with them in any capacity you would with an actual bank employee, right? Uh, Similar things exist everywhere for driving license or for passport or like any other government office or any other place, right? There are lots of places where you actually need buffers, where you have human buffers before any service is actually catered, right? So that would be the thing. And another thing is that if that while you can focus on that, another thing would be that you actually try to be something like Sakana AI Labs or something else, and then and then try to good stuff, different stuff which nobody else is caring about or thinking of, and then do something fascinating which gets used by others. People want to back you up. You want to appear promising, even as a small research lab. Even if you can't really compete with everyone else, you want to appear promising that others want to back. And then using their backing, you get compute, you attract talent, and then go for the same thing that others are going for. Yeah.
I guess that pretty much give the context about as this Indian AI space is evolving, recent developments from Indian AI, and I guess like we will be doing pretty much in deep tech areas as well. Let's say biology or material science. I guess this covers the context. The next last question would be, I guess we are already over 2 hours in the podcast, but yeah, let's say I guess this the yeah, pretty much last question. But yeah, if you had to start over as a student in 2025 or in the later year 26, 27, with everything you know now, what would you do differently and what would you ignore and what would you double down basically? Yep.
Yeah. So one thing is related to what I already told you earlier about treating these systems as capable systems and then working uh, in backwards fashion from there to actually get out of them what you really need. Learning to engineer context, learning to do anything, right? Second thing is uh, developing true ownership. I really believe that anybody right now, like even if you're a high school person or studying in class, studying in 12th standard or undergraduate or anyone else, the one thing that you really should understand and recursively ask yourself, like if you don't understand it in one go, you need to like repeatedly ask yourself, how can I develop true ownership of this thing I really care about? When I say true ownership, it would mean that right now if you're dependent on like five people to do something, and those five people could be your teachers, your five people could be someone who's deciding what area of research you should work on next, or anything else, right? So any kind of human that you yourself are relying on in any for any degree of intelligence. First, you have to recursively ask yourself this question: how can I uh, move up in abstraction in such a way where I can automate my dependency on all of these individuals? on
True.
something which already exists at current level of intelligence.
True.
What would it take?
True.
Master that, and then become a hyper unit yourself, become a team yourself, become someone who can just observe a group having some difficulty and then have the incentive to offer them a solution for their problem. And now, and after that, whether you do it for open source charity, or whether you do it for money, or whether you want to like take it forward and then build a business or of sorts, that's entirely up to you. But the one thing that you should really, really care about is moving up one degree of abstraction and then developing true ownership. And if you don't get it in one go, recursively ask yourself how to do it.
Is this true ownership is what Karpathy or other people meant what is they call agency? If they somehow relate to this.
Agency is okay. So this is how I would define agency. Agency is like being in a dark room
Yeah,
and not being told anything except the fact that you don't want the room to be dark. So you you basically mess around the room in such a way so that you can find the switch. If you can't find the switch, you invent the switch. Okay. So agency is basically having zero blockers. Agency is basically burning down agency is basically burning down anything that stands between what you want and what you have.
true. Um, cool. I guess we have covered a lot of things from open source, um, post AGI, pre-training, post-training, agents, RL. I guess we have covered a lot of RL questions here. Um, all right. I guess this was epic. Thanks a ton for coming on and just being insanely real about this current, all about AI, the chaos, RL, post-training, open source, all of it. Honestly, learned a lot and had a lot of, on it on sometimes. I really appreciate you sharing the actual and grind and what goes on behind the scenes and landscape. Hope everyone listening and found something that they didn't expect, or at least got a few ideas to steal and give a shot to next new experiment. Thanks a lot. This was a blast, I guess. If you have something to share to in the last, so probably you can. Yep.
Yeah, it was fun for me as well, and thanks for having me. And I hope that most of the people who are trying to move forward but aren't able to move forward because uh, of certain kind of limiters they have put on themselves, or they don't have good examples around them with which they can actually think that okay, if uh, something just can't be done. I really hope that more and more people uh, get connected together so that we are uh, we- we're capable of building good culture for any student in India ourselves,
Yep.
right? I really feel that is one of the most important things, and maybe the things will change with you guys, or maybe the things would change for the next generation of students. But the most important thing would be that wherever we are, we have to like start building culture and let the culture mature in a unique fashion for India, because the way we can care about the way we understand about our own country, or the way we understand about our own problems, nobody else does,
Sure.
right? And that's also how we generate value, or do anything useful. Yeah.
Yeah, for sure. We really hope like we'll be getting some good insights, good things coming up, at least on Twitter. And people who don't know about him, go follow Tokenbender on Twitter. See his experiments, is fun. Lot of things to learn from. And I guess that is enough. We should wrap up. Thank you.
Yeah,
Okay.
thank you.